Spring, Quarkus, Jooby, Vert.x, they can all help you build Java services, but they come with different powers and limitations. Today, we will turn the usual framework war into the decision map for teams who care about shipping fast today and surviving maintenance later. How do you decide which framework fits your project goals and long-term needs? Not by the fame or hype, of course. I'd say that selecting a framework is like selecting the RPG character at the start of a very long journey. Each comes with a distinct personality, constraints, strengths, and the playstyle that shapes every decision along the way. So before committing to a playstyle that you didn't intend, ask yourself these questions. What kind of app do you want to build? A simple service, a complex enterprise platform, or a reactive event-driven system? How fast can a team ship and update the features? How well does the framework integrate with the solutions that you need? How much framework ceremony, manual plumbing, or hidden magic exists? How much memory does the app need in production, both in terms of the image size and memory consumption? How expensive will this framework be in several years to maintain? Will this framework still be safe, supported, and reasonably painless to upgrade in the future? What execution model does the framework expect? So now, bearing in mind these questions, let's look at 4 Java frameworks. Spring Boot has become the de facto enterprise default. Its whole pitch is standalone, production-grade Spring applications that you can just run, with opinionated starters, auto-configuration, embedded servers, and production features. If we look at the demo, we will see that the most code is about defining the business logic, while Spring does all the rest. We have clean, annotation-based controllers, declarative validation, GPA-style repositories, profile-specific configs, actuator health metrics, and test containers integration. The ecosystem is huge: security, data, messaging, validation, batch, cloud config, integration, REST clients, you name it. Spring also supports AOT optimizations, layered jars, cloud-native build packs, and GraalVM native image for optimized performance. As for the limitations, Spring is not the lightest framework. It pays for its convenience with runtime abstractions, dependency graph size, and startup cost. So, startup and memory are usually not its selling points unless you opt for AOT or GraalVM native image. Spring has frequent releases and mature release notes. The releases come with bug fixes, documentation improvements, and dependency upgrades. There's also a clear support cycle with open source and enterprise updates schedule. Controllers, services, repositories, validation, exception handling, that is all very concise and familiar. Actuator and test containers are a drop-in. For hiring Java backend developers, Spring Boot is the keyword. LinkedIn currently shows thousands of Spring Boot jobs in the US alone. You can find engineers with any level of expertise in Spring, from junior to senior. Quarkus is built for containerized Java. It aims for fast boot time and low memory usage on Hotspot and GraalVM. If Spring came to support Cloud Native, Quarkus was born Cloud Native. It is designed around build time augmentation and native image support. Also offers first-class support for deployments on Kubernetes and OpenShift. This is thanks to the strong Red Hat ecosystem, extension, config, health, metrics, OpenTelemetry, and reactive stack options. If we look at the demo, we will see that the structure is familiar to that of Spring, but with a few alternative solutions, such as Quarkus REST checksum, Hibernate ORM panache, and small RAI health. It is close to Spring in structure, with a few more straightforward paths. Quarkus is more opinionated around build time behavior. This is exactly why it performs well, and why some libraries need Quarkus-specific extensions to support it. Native images are powerful, but they add to build complexity. The talent pool is smaller than Spring's, although many Java developers can learn Quarkus quickly, especially if they know CDI, JAX RS, or Hibernate. The LTS cadence is clear. Every 6 months, 1 year support, critical bug and CVE fixes, and overlap for upgrades. Maintenance cost is similar to Spring for full enterprise applications. This is because Quarkus gives you a platform with extension registry, health, config, persistence, test and dev services, and upgrade tooling. It might be a little bit higher than Spring in some use cases, because fewer people know the rough edges. Coding with Quarkus is a great experience. The dev mode enables true live coding, where code changes are automatically reflected in the running application. The dev mode can also be used remotely, so that changes to local files are immediately available in a containerized environment. Also, Quarkus supports continuous testing, where tests run immediately after the code changes are applied. So, for a Quarkus-literate team, the delivery can be very fast, especially for Kubernetes native services. This is because Quarkus provides dedicated tools and extensions for Kubernetes deployments. You can hire Java developers and train them in Quarkus, but senior Quarkus production experience can still be more rare than with the Spring Boot. Jooby is the lightweight, clean, and small option. Its documentation describes it as a highly modular, high-performance Java and Kotlin framework with a choice of Netty, Jetty, or the Undertow as a server. It also offers low memory usage, fast startup, hot reload, open API support, and thin modules. Plus, you can use only the required modules. For example, if we look at the demo, we will see that the routing is done in a more straightforward way than with Quarkus or Spring. Also, instead of a JPA, Jooby offers the JDBI module. This one sits in between ORM magic and raw JDBC. All in all, it is good for small services where teams want to see exactly what happens. Jooby is not the obvious enterprise standard. Its cost is that you assemble more pieces yourself. Compared to Quarkus or Spring, it has fewer official integrations or battle-tested enterprise recipes. The framework itself is active and supports the fourth and the third versions according to its security policies. Recent releases include the added modules for gRPC, JSON RPC, and LangChain4j modules. The repo also shows active CI and dependabot activity. But enterprise maintenance is not just about is the repo active. It is also about security advisories, dependency alignments, upgrade playbooks, observability defaults, platform convention, and hiring. Jooby's smaller ecosystem may mean that the team will have to write more glue code. You decide conventions for layering, error model, observability, authentication, config, and testing. And this glue becomes yours forever. The routes and modules in my demo are straightforward. But as soon as you need authentication, audit logging, distributed tracing, policy enforcements, and other enterprise-grade features, Spring and Quarkus pull ahead. As for the hiring, you hire Java developers, not Jooby developers. That can work if the team is senior and values simplicity. But it can be risky if the company expects easy staffing, rotation, or outsourcing. Vert.x is often called the framework, although technically it's a toolkit for building reactive applications on the JVM. It was specifically designed for high-volume messages, large event processing, HTTP interactions, and cloud-native applications. Official docs emphasize non-blocking APIs and warn explicitly: do not block the event loop, or else the application may grind to a halt. But for reactive applications, Vert.x is great. It provides async DB clients, tools for handling many concurrent connections efficiently, and lets you pick the model that works best for the task at hand. Callbacks, promises, futures, reactive extensions, and Kotlin coroutines. Vert.x is not Spring in faster shoes. It's a toolkit. It means that it gives you the building blocks, not the full enterprise application model. My demo doesn't really pay tribute to Vert.x. It doesn't use its reactive powers extensively. Rather, it shows how much code you will need to write for a simple CRUD application. You need to do explicit config loading, manual PG pool creation, router setup, validation, error handling, and async service and repository flow. On the one hand, it is clean and straightforward, and what you write is what you run. On the other hand, it may feel like inventing the wheel in more complex scenarios. Vert.x itself is stable and active, but using it as your core application platform means that the team will have to maintain the architectural conventions Spring and Quarkus otherwise provide. The speed of delivery also depends on the type of application you write. It is the slowest for ordinary enterprise CRUD applications. The demo proves it by showing that Vert.x has the highest lines of code ratio and the most manual setup. But the delivery can be very fast for specialized async systems, especially if the team already knows Vert.x. For APIs that need high concurrency, event bus patterns, reactive DB access, streaming, WebSockets, or custom protocol handling, Vert.x can be excellent. The talent pool is mixed. There are more developers who know Vert.x than they know Jooby, but less who know Vert.x than they know Spring. You can find Vert.x specialists, especially among the backend engineers, but average enterprise Java hiring pipelines are Spring heavy. Without digging into hardcore benchmarking, let's look at the most obvious comparative parameters: build time, container image size, lines of code, and times of a startup in a container. But these numbers are by no means carved in stone. They are based on the default parameters without any tuning. For example, I did not enable the AOT processing with Spring, which may improve startup time. Nor did I build native images. This is the subject for a different video. As for container images, I have built them using Docker multi-stage builds and hardened Liberica runtime containers for enhanced security. Hardened Liberica runtime containers are minimalistic and come with low to zero CVEs by design. Okay, let's look at these parameters briefly. First, lines of code. As we can see, Spring has the lowest number of lines of code, and Vert.x has the highest. As for the container image size, the Spring Boot container is the heaviest one, then follows Quarkus, then Jooby and Vert.x. The build time is the highest with Quarkus because of different build time optimizations that we mentioned. Jooby and Vert.x yield the fastest starting containers. If we compare Spring and Quarkus, we'll see that the Quarkus-based container starts much faster than the Spring-based one. Okay, we'll look at 4 frameworks: Spring, Quarkus, Jooby, and Vert.x. Spring. It is the enterprise default, it has the lowest organizational risk, and also it has the strongest hiring and long-term maintainability rates. Quarkus. It is an interesting, modern, cloud-native enterprise platform. It's good for teams who are comfortable with Kubernetes, native image trade-offs, and Red Hat ecosystem. Vert.x. It's a specialist toolkit. Choose it only if your architecture genuinely benefits from async model. Jooby. It is a minimalistic choice for small services. Enterprise adoption requires a senior developer team and acceptance of a smaller ecosystem. The link to the demo using all 4 frameworks is in the description. Don't forget to like this video, subscribe to our channel, and until next time!